background. He's an astrophysicist. And so I think his entrance theme should be Twinkle, Twinkle, Little Star. Okay? So I'm going to get you guys to sing it, and as you sing it, he'll make his way up here. Alright? Okay, 1, 2, 3. Twinkle, twinkle, little star, how I wonder what you are.
Well, I have an idea. Okay, you ready? Yes. So, this half of the room sing Twinkle, Twinkle, Little Star at the same time that this half of the room sings A, B, C, D, E, F, G. Because it's the same song. Did you know this? Yeah, okay, let me hear you say it. Sing your ABCs, ready, go. Okay, you know that. Okay, start Twinkle, Twinkle, Little Star. Ready, go. Okay, okay, so you ready? Simultaneously, you're gonna sing Twinkle, Twinkle, Little Star and ABCs. You ready? Okay, ready, go.
The next time they're trying to spell, they'll be singing Twinkle, Twinkle, Little Star. Okay, we go one.
Yeah, I almost sat on this. That would hurt. Yeah.
Did you put it there? Did you put this there? Okay. All right. Now, Neil, or you can call him Dr. Tyson.
No, my name is Neil. You call me Neil.
Okay. Now, he's an astrophysicist. Does anybody know what an astrophysicist is? Okay. What is an astrophysicist? You are not. Yes.
Someone that studies space and how the world started.
That's good.
Okay.
And world with a capital W, because there's Earth as the world, but then there's like the universe as the world. In the old days, world meant the whole universe. And so, yeah, we care about how it began, what's going on now, what it's going to do in the future. Yeah.
All right. So tell us, what else does an astrophysicist do, and how did you get involved? How did you become an astrophysicist?
Well, are you allowed to ask me questions?
Well, yeah, I should. This is for the kids, and I'm the biggest kid here.
So, no, well, how old are you, is everybody? 12, 11, 10? I was 9 when the universe said, "Psst, come study me. I'm really cool." So I went to a planetarium, and they turned out the lights, and the stars came out, and I said, "Whoa, this is cool stuff." And I saw the planets and the moons and the galaxies. And so I've known I like the universe ever since I was 9 years old. And so you guys are 10, 11, 12. Who's here is 12? You got some 12's here? And you're 11? You're how much? 11, okay. And anyone who was 10? Anyone here is 9? 9, okay. Anyone here who is 4? No.
All right, who wants to be an astrophysicist when they grow up? Quite a number of them here, okay? Who would like to ask the first question? Okay. Yes. Loudly. What's your name? Luke. All right, Luke. What do you
Luke
have?
or Duke? Oh,
Luke.
so I can say Luke. Luke. Use
Okay,
the force. Luke.
What's your question, Luke?
Use the force. If the universe started with a big bang, how will it end? Right now, we are expanding. The entire universe is expanding. And it is expanding so fast that it will never recollapse. There will never be a big crunch. There will never be a big squeeze. We are on a one-way trip to oblivion. And as the universe gets bigger, the temperature drops. The temperature of the universe gets colder and colder and colder. And it approaches the coldest possible temperature. Oh, you want to use that to solve the global warming problem? Yeah. So the universe will end not in fire, but in ice. The universe will end as infinitely large, and all the processes will cease. The stars will burn out. In the night sky, you will see the stars dim away one by one, and the universe will be dark. Have a nice day. Yeah. So that's how the universe will end.
The good news is you'll save on your air conditioning bills.
Yeah.
Who else has a question? All right, this gentleman.
Well, all our evidence shows us that the universe began with a really big bang, and we call it the Big Bang. You see, in my field, we call it just what it looks like to us. And we have a lot of one-syllable names of things. So, for example, when we find spots on the sun, you know what we call them? Sunspots. Yeah, see? Sunspots. Jupiter has a big red spot on it. It's a storm. We call it Jupiter's red spot. You see? That's how that works. Okay.
Okay, how about you? Louder, louder. I cannot hear you. Yes, what's your name?
What makes stars twinkle?
Oh, what makes stars twinkle? Yeah, so twinkling stars. It is entirely our atmosphere. So the starlight comes through the depths of space, and it is a perfect pinpoint of light. And then it hits Earth's atmosphere, and some parts of the atmosphere are warmer than others, and it gets bumped and jiggled, and by the time it comes down, you see all these different paths of light merging together, and the star, if you zoomed in on the star, you'd see the star moving around like this. That's the atmosphere changing where it looks like it is on the sky. And when you look at it, it looks like it's twinkling. And people think that that's a good thing. It's a bad thing for astronomy, because we're trying to focus in on the star. If the star is jiggling and getting brighter and dimmer, that's bad. That's why we made the Hubble telescope. Where is the Hubble telescope? In space, thank you. It is above the atmosphere so that we don't have that problem.
Okay.
Why is space dark?
Why is space dark? Ooh, well, it's not actually dark. Well, stars are in space. So if you look towards a star, you see the star. What you're thinking of is, how come, is that rain outside?
Oh, it is raining.
Wow. Cool, we got it just in time. Cool. It's not that I haven't seen rain before, but it's like raining really, really heavily, and there's like no indication of that walking in. So, here's what happens. On Earth, there's air that you breathe. It's our atmosphere. The sun, coming through the atmosphere, gets its light scattered into the air. Into the air. And the air prefers blue more than it prefers red. Sunlight is all the colors of the rainbow. Red, orange, yellow, green, blue, violet. All those colors together are coming from the sun. You know that because you see a rainbow. It has all those colors. So the air scatters the blue light into itself. So what color is the air? Blue. you don't say air is blue. What do you say is blue? The sky is blue. We say sky, and part of the reason why you get blue water, the sky is blue. If you didn't have the air, the sky would be no color at all, and you'd see straight out into space, and the sun would be there, and stars would be there, and it would be dark in between. That's exactly what the sky looks like on the moon. On the moon, in broad daylight, the stars are out. Because there's no glowing atmosphere to prevent you from seeing it. So, space is whatever light you happen to be looking at, and there's nothing in the space to glow unless there's a cloud, a gas cloud. And do we have one here? You have gas clouds. Actually, this is me. Is that me? Does that look like me? Yeah. So this is, you can have gas clouds in space. This is the Cat's Eye Nebula. No, sorry. No. The Cat's Eye Nebula has it looks like a cat's eye. This is actually the Helix Nebula. But we put an eye in the middle just because we want you to think the universe is looking at you. Yeah. So you can have clouds in space, and then the clouds can take on colors, just the way our atmosphere does. But if there's no clouds, no atmosphere, it's dark. Good question. Yeah, next.
Okay, yes. Louder.
Who's next?
Didn't you put up your hand? You want to ask a question? Or are you just waving your hand? Okay, we'll wave back. Alright, well.
Can you list a couple of things, maybe 3 that are popularly known, but more of science fiction than
List 3 things that are popularly known that are science fiction?
more science fiction.
That's more science fiction than fact. Okay, that aliens are just walking among us. Science fiction. Okay? 1. 2, that you could just go into space and turn on your hyperdrive and hit light speed. Every science fiction movie does that now. Star Trek, Star Wars, everybody does it. We can't do it. We don't know how to do it. We haven't figured out how to do it. 3rd, that I'm trying to come up with a 3rd one. Those are the big ones. That aliens are just everywhere and you can hang out with them, and that they speak English. Yeah. I know. I don't know what they would speak. It wouldn't be English. Most people in the world actually don't speak English, right? So why would aliens speak English? I can't think of a 3rd one. Let me think of one. And I'll get back to you later on that. Okay?
Okay, we had this question that actually came into us yesterday. Since space has no gravity, will my baby teeth float away out of my mouth if I don't close it in space?
I assume the baby tooth is loose and came out.
Yeah.
Right, because if you have baby teeth and you go into space, they all going to come out of your head. Okay? Right? That's, I assume.
Yes.
Yes, okay. There is gravity in space. In space, you will fall towards whatever is the strongest gravity that's near you. But while you're falling, you don't feel a force of gravity on you. You're in what's called free fall.
Okay.
And so all the astronauts, it's not that they're in space and there's no gravity. The astronauts in space are in what's called free fall. And when you're in free fall, you do not feel the force of gravity and you are weightless. So if your tooth comes out in space and you're just floating there, you're drifting towards whatever nearest object is there, the moon, Earth, the sun. Yes, your baby teeth, provided it came out on its own, it will just float away. But you need your baby tooth for the tooth fairy. So go and get it back. Yeah. Oh, you want the tooth fairy to look for baby teeth in space. That's the space tooth fairy. Yeah.
All right, kid in the black t-shirt, go ahead.
Where would, if
teleport to anywhere in space, like with space stuff, where would you go and why?
Nearby space or distant space? Does it have to be now, or can I go anywhere in time? Now. Now, I would go to Jupiter's moon, Europa. That moon has an icy surface, but the gravity of Jupiter is pumped into it, and it has melted the inside of the moon. So Europa has an ocean of liquid water that's been liquid for billions of years. And on Earth, where we find liquid water, there's life. So I want to go ice fishing on Europa. That's where I would go now. Yeah.
The Earth is also thickest at the equator, so would gravity not be strongest?
You are correct. Yes, so there's a lot in that question. Earth is not a sphere. Earth is wider at the equator than it is at the poles. So there's a word for that. You want to hear the technical word for it? Oblate spheroid. Everybody say it. Oblate spheroid. Okay? Oblate spheroid. Earth is, now it's worse than that. Earth is slightly wider below the equator than at the equator. So Earth is a pear-shaped oblate spheroid. And if you are farther away from the center of the Earth, you have less gravity operating on you and you would weigh less. So you weigh less on the equator. So if Santa Claus were on the equator, he weighed less than he would weigh on the North Pole. Now right here, we're basically on the equator, right? Aren't we basically on the equator here in Singapore? Yeah. So you weigh a little less for being on the equator than if you had a perfect twin who would be visiting Santa Claus on the North Pole. Not only that, do you know how fast? Not only that, do you know how fast we are moving because Earth is turning? You know how fast we're going? Let me tell you.
Wait, everybody else, how fast?
Because Earth is spinning, and we're all near the equator. We are spinning fast. We are going, we convert to kilometers, we are going 1,500 kilometers an hour right now. You don't feel it because Earth is carrying you with it. But if Earth stopped rotating right at the second, you would keep, unless you had on a seatbelt connecting you to Earth, you would fall over and roll due east at 1,500 kilometers an hour. You don't want Earth to stop rotating. Just advice.
Okay. Can't hear you yet, louder.
Because the light of a star takes time to travel, possible that by the time the light of that star reflects on Earth, it is already destroyed?
Yes.
Yes.
Next question. Yeah, except. Did everybody hear the question? Since it takes light time to travel, could it be possible that a star's light, in the time it took to reach Earth, maybe the star is no longer there, is destroyed? The answer is yes, is the answer to that question.
Yes.
However, the light from you takes time to reach me. Just the way it takes light time to go from a star to Earth, it takes time for you to reach me. And it will take about 5 billionths of a second. Now we can ask, have you changed much in 5 billionths of a second? Could you be dead by now? You live a long time, much longer than billionths of a second. So you are close enough to me so that I can describe what you look like and not worry that you've changed much in 5 billionths of a second. So most stars are close enough to us, most are close enough to us that they haven't changed much compared to how long they last. So a star could be 10 light years away, but they live 1 billion years. What's 10 years difference? Now, some stars do die, and we don't know it until that light reaches us, but they're rare. They're extremely rare. One in a galaxy every 100 years. So, it's a great question. You have to compare how long it took for light to reach you with how long the star is going to live. That'll give you an idea of whether you're seeing things as they are, rather than as they no longer are.
Yeah. You have a question? Yeah.
What is the shape of the cosmos? The exact shape? The exact shape? Okay. We can only see to our horizon. And our horizon, that exact shape is a sphere. A sphere. Well, so, right. So, we can look in every direction. So if you're on the ocean, and you look on your horizon, that's a circle. And it's an exact circle with you in the middle. Is that the whole ocean? No, it's just your horizon. You can't see beyond your horizon. A different ship has a different horizon. But the horizon is an exact circle. Now the universe extends in every direction. So I look up, I look down, I look this way, I look this way. I can only see the same distance in every direction. What shape do you get if you look the same distance in every direction? A sphere. So the shape of the observable universe is a sphere.
There you go. Write it down.
An exact sphere. Yeah.
All right, Princess.
Can anything escape a black hole? Not really. No. Oh, good.
Yeah.
Black holes will lose their mass, but it takes a really long time, and you don't want to wait around for that. So basically, when you fall into a black hole, you are never coming out. Tell everybody goodbye. Okay? So you should avoid black holes. As you see a black hole coming, just go the opposite direction. Okay? Yeah.
All right. Yes. Lucky you.
How many galaxies are there?
Billions and billions. So in the observable universe, there's between 50 and 100 billion galaxies. And the Hubble telescope helped us come up with that number. Between 50 and 100 billion.
Is there a chance we'll see
By what time? By what year?
2015.
2015? 50. You mean in 35 years, 36 years? A human landing on Mars.
Yes. But they tried this bit.
I know. Maybe. Maybe. That would be, if we were to do it at all, we would do it by 2050. If we don't do it by 2050, go home. Now, I like to think that you guys are that first astronaut class. That's what I like to think. I'll be dead by then, okay? You guys will be alive and kicking. If we select astronauts, we're gonna go to the 10-year-olds, the 12-year-olds, 13-year-olds, because by the time we're ready to go to Mars, we want you to have been trained to do just that. to go to the trip. So, yeah, if we go at all, it would be by 2050. If not, take up another profession.
All right, in the gray sweater.
What inspired you? Who was your idol to become a astrologist?
Astrophysicist is what I am. Yeah. So, no, there was not a person who was an idol. There were several people who did different things, and I stapled them together into one person. So I met one person who knew a lot of science. I said, I want to know that much science. I met a person who was a good educator. So I want to be an educator like that. I met someone else who had a good sense of humor. I said, I want to be that. And I glued them all together, and that became the combination person of all those people. That became my idol. So no one person, bunch of people.
How many years does it take to study as a physicist?
How many years? So I went to college and I majored in physics. Then I went to graduate school. College was 4 years. Graduate school was another 6 or 7 years. So it's like 11, 12 years just to study the universe to become an expert in it. Then you step out there and make discoveries. That's the fun part. But it's a long time in school. But I like school. These people say, oh, I can't wait till I get out of school. What? I said, but in school, you're learning. You're learning about everything. Learning. Keep learning. Look, now what's wrong with learning? I like learning. Right? So, yeah, so it's a long time in school, but then you become out to be an expert. Yeah.
Did you have a question? No. Okay.
Can humans live on another planet? Is there something wrong with Earth? Do you have a problem with Earth? Are you trying to leave Earth? Okay, so here you go, you ready? If you go to Mercury, you will turn into a puff of smoke because you are so close to the sun, all of the atoms in your body will vaporize. And that will happen right around the time you suffocate because Mercury has no air. Venus has air, except it's even hotter than Mercury. You would vaporize even faster. But you could cook a pizza in 3 seconds on Venus. Mars rotates once every 24 hours. It has polar ice caps. It has seasons. But there's no oxygen there. If you go to Mars, you will suffocate because there's no oxygen in the air that you breathe. Asteroids, that's what's next in the solar system. They don't have atmospheres, forget it. Jupiter is all gas. If you try to land on it, you'll just keep sinking down. How about Jupiter's moons? How about Jupiter's moon Io? Io is the most volcanically active place in the entire solar system. If you move to Io to be a volcano, repaving what you're sitting on with lava, it does it all the time. Your house would incinerate in the lava flows. Saturn has a moon called Titan. It is cold on Titan. What is normally breathable air on Earth is liquid on Titan.
What?
Liquid, that's how cold it is. You'll freeze to death. And the sun will be this dim star in the sky. So Uranus, also made of gas. Not a place you would land. And that's planet Uranus, exactly. So, no, there's no other place you can live. That's my long answer to your excellent question.
All right, we got time for just 2 more questions. Who hasn't asked a question yet? Okay. Do you have a question you want to ask? Go ahead, yes. Do you believe in aliens?
Who asked that question?
This,
I didn't hear him ask it. Do I believe in aliens? The universe is big. The universe has been around a long time. The ingredients that make up the human body are everywhere in the universe. And latest data tells us that there are more planets than there are stars. So if you look at that question, we are probably not alone in the universe. And if we're not alone, they'd be aliens on other planets. So if you ask any astrophysicist, we will all answer that there probably are aliens in the universe. Now, have they visited us? I'm not convinced. Just because someone tells you they were abducted by aliens doesn't mean they were abducted by aliens. I need better evidence. You know what would make good evidence? Here's what happens, okay? If I get abducted and she's the alien, okay? So I would say, alien, yeah, put the little antenna on. So I say, alien, come with me, and we'll go and we'll show her to everybody. And I say, look at my alien. There's my alien. And then we poke you and probe you and see what you're made of, and we'll check out your antennas, and then we're fine. So what happens is, people say they saw aliens, but they don't bring the alien with them. And they go tell you that they saw an alien. That's not good enough evidence. So if any of you are abducted by aliens, invite the alien back with you. Okay? Show your parents. Show the government. Okay? Take them to the TV station. They'll put the alien on TV in a minute. Okay? So no, I'm not convinced by anything that people say about aliens on Earth. I think if they're really here, we would really know it. They wouldn't be hiding from us. They wouldn't be shy aliens only landing at night on farms. They would know where the cities are. So I want to meet the alien when they come, and I'll bring them and parade them around.
Okay.
Next.
How do you measure the distance to other objects?
That's an amazing question. It took us decades to figure out how to do that. I'll show you one way. You ready? Okay. Everybody take their thumb and hold it out and put it on his face. Okay? Now, close one eye and line up your thumb with his face. Is his head completely blocked out? Okay. Now, switch eyes. Okay? Now, notice your thumb is his face is in a different place. Did you move your thumb?
No.
No. Did he move? No, but now he's lined up in a different spot. Okay? Now, but do this with your arm at arm's length, full arm. Okay, so do it again. Get a note of that. Notice how far back and forth his head moves as you blink from one eye to another. Okay, can you see that? Okay, can you see that? Okay, now bring your thumb in closer and do the same thing. Line up your thumb with his face and flip your eyes back and forth. What happens to his head? That's too close, about right there. Yeah, his head moves more back and forth. So, in the universe, we look for that effect, not with our thumb, but as we orbit the sun. When we're on this side of the sun, we have a view of a star against the background. And we take a picture of that. Then we come around to this side of the sun. Now that same star is in front of a different background. And so you can calculate how much that star is swinging back and forth, and that tells you exactly how far that star is. And it's just the same thing that you're doing with your thumb and his face. Now you weren't moving your head, right?
Not at all.
Not at all, okay.
Not at all. All right, ladies and gentlemen, looks like we've come to the end of our question and answer session with, of course, Dr. Neil deGrasse Tyson. Can we have a big round of applause for him? Of course, don't forget to catch him in his brand new show, which is going to be making its premiere next month on National Geographic, which is on the 15th of March at 10 p.m. Tell your folks to get that wonderful channel for you, and of course, you'll be able to catch a new show, which is called Cosmos, a Space-Time Odyssey. Once again, a big round of applause for our special guest today. All right.
Oh, cool. Autograph. Sure.
I'll be like, I'm here.
Got it.
How much?
Okay.
150.
I'm definitely not going to do this to my sister.
Yeah, I couldn't fit under my butt. That's the problem. All right. You can ask like 3 questions.
I had 3, but yeah.
Yeah, I know.
But yeah. Thank you.
Got it.
It's gonna go for my profile picture forever.
Okay, sure.
Yep,
Sure.
My selfie went out pretty good.
Like, yeah, I got the profile picture.
Tim took about 5 minutes.
Yeah.
And it'll have like millions of likes. He just posted 5 minutes.
All right, thank you. Yeah.
So many people.
Yeah. Success? Okay, you ready? Success. Success is doing what is hard, not what is easy. Some people take easy classes like when they get to college. And then they get high grades. But they get high grades in things that are easy. And easy means that everybody else can do it. Is that what easy means?
Yes.
If something's easy, it means everybody can do it. So if you get a high grade in something that's easy, then there's nothing special about you. Because everybody did it. So you do something that is hard, and if it's hard, it means not many other people can do it. And then when you do what's hard, then people come to you because you accomplished it. President Kennedy, 50 years ago, said, "We choose to go to the moon not because it's easy, but because it's hard."
I just want to ask you, do you know Bill Nye?
Yes, we're friends. We're good friends. Yeah. I speak to him like a couple of times a week. I mean, email or phone or text. Yeah. And what did I say?
He said
Doing
something hard.
doing what is hard, not what is easy.
I'm gonna say that tomorrow. And it's gonna be like, oh my gosh, I said that.
But who are you going to tell it to tomorrow?
The day Saturday maybe? Oh wait, tomorrow.
It's Saturday.
Monday then. Well, I'll tell her.
Today's Valentine's Day. Yeah, happy Valentine's Day. Germany? You want me to sign that?
In the morning.
That takes a long time to write.
Let's do it.
That takes a long time. Success is never giving up. People say, I can't do it, I give up. Don't give up. Ask people. You know, work at it. Yeah, that's yours. Okay.
I've got 2 questions to ask.
Sure.
So, which school or college would you recommend for a person that wants to go and be an astrophysicist?
Oh, there's a whole bunch. So here, there's the. There you go. Well, I know the ones in America. I don't. There's a few around the rest of the world, but I know more about the ones in America than others. Here's what you do. DAS.org. American Astronomical Society.org. It'll go straight there. And you're going to look up, surf those pages and look for a section for students, and it'll give a list of schools that do have good astronomy programs.